Okay, let's get going on this one. Yesterday, in video 14, I was starting to show you a little bit about these irrational numbers. That is, these numbers with the hat over it. And we agreed to include pi in these kinds of numbers as well. We're calling them irrational. And we're going to talk even more about that down the road so that you can start getting your high school education going. And you'll understand these little guys when they pop up. So anyway, the question was, what is the measurement of a diagonal of a cube when the edge is 1? And that's a question that's worth asking, because after all, no one can say I'm asking you an abstract question, right? And I also asked about the 6 faces of what their length would be. We'll do that afterwards. First, let's do the cube, the length of the diagonal of the cube, and then we'll talk about the lengths of the diagonals of the faces. So I need to solve this problem, and curious what number is going to pop up here. You should be saying, wow, man. So I draw a diagonal here, and then I draw another diagonal here. And I realize that if I know one diagonal, I know the other diagonal. So I only have to find one diagonal and multiply it by 2, just like I did yesterday with the square. So here, this guy is 1, and this guy is 1. See the right triangle there? See it? One leg, hypotenuse. So I write a squared plus b squared equals c squared, and just replace what I need to know. Well, what do I need to know? 1 squared plus 1 squared equals x squared. So we'll call this x and we'll call this y, just to make our ideas clear. Well, 1 squared is 1 and 1 plus 1 is 2. So just like yesterday, nothing's changed. The diagonal here of x is 2. So I just write radical 2. So I got that part down, and now all I have to do is worry about the answer that I'm seeking. So let's see what I have. If x equals radical 2, I can put it here, and now I have a new triangle. Do you see it crossing diagonally across the cube? It's here like this, and so radical 2 is a leg, and then 1 is a leg all over again, since it's a cube. So ready? We'll let it go here. We have a squared plus b squared equals c squared. But this time, one of the legs is radical 2 squared. The cube makes this 1 squared. And there, that's going to equal y squared. So we're differentiating x and y, just to make sure nobody gets confused. But you've been taught already, any radical times itself is the number under the hat. So this is just 2. And 1 squared is 1 equals y squared. And 3 equals y squared. And we come up with this surprising answer that the diagonal of any cube, when they have an edge of 1, is radical 3. And there you can see it again, how these numbers pop up with no mercy in the simplest shapes that we can imagine. And I'll continue to show you ideas like this. So when you see radical 3 or radical 2, you shouldn't be surprised at all. What do they equal? Well, we know this is around 1.7. What is radical 2? It's around 1.4. But we'll talk more about that later. Okay, so as I do this problem now, I'm just going to tell you the length of the diagonals of the faces. Well, yesterday, when we did a face, and we did a diagonal here, and we put the right angle sign right there, we get the same answer as yesterday. We get radical 2, but there are 2 each. And by the way, the proper answer to the question that we just did is radical 3 plus radical 3, which is 2 radical 3. Sometimes I lose my train of thought. That's the answer to this, as been previously explained. And here we have radical 2 plus radical 2, which is 2 radical 2. But how many faces are there? There are 6 faces. We've done that together in class. So the answer is this strange number, 12 radical 2. What is it if you put it on the calculator? 2 times approximately 1.4 whatever as it goes on. Okay? So we'll talk more about this. And now I'm going to give you another question. And it will be a fairly easy question, but a lot of interesting things will follow from that. If you followed what I was saying, I'd like you to calculate the diagonals, okay? The length of the diagonals of a cube if the edge equals 2. And there'll be some surprising things going on there. And I'll talk about it when I do the problem and then maybe teach you a little bit more on that. And before I end the lecture, because I do have a couple minutes here left, let's take a look at something. We already said that radical 2 plus radical 2 is 2 radical 2. Okay? And we said that radical 2 plus radical 2 plus radical 2 equals 3 radical 2. So you see these radicals act like terms, okay? And further press home the point, ask the question, what's radical 2 plus radical 3? Well, the answer is, that's the answer. These are unlike terms. You can only add radicals when the same number appears under the hat. And I'll answer another question that kids often have for me, since I have a little time here. The question would be, we know, for example, that radical 2 is irrational. Well, is radical 2 divided by 2 irrational? And the answer is always going to be yes. If you attach a radical to any number, the whole thing becomes radical. It's like a poison that envelops the whole body. Anything attached in any way to a radical is irrational. So that would even include radical 2 plus 1. I can't do anything more with this number. This number is whatever radical 2 is plus 1. They cannot be combined. And their answer is irrational as well. And that will come up as we're working along in math. And then the question comes up, can you square these guys? Absolutely. We'll probably do so. Can you do what's a radical divided by a radical? The answer is always a radical, unless irrational radical, unless, of course, the number under the hat are both perfect squares. So what I mean to say, radical 9 divided by radical 4, since 9 and 4 are perfect squares, is not a radical. But perfect squares, numbers under the hat other than perfect squares, are always going to be irrational. So there you have an example where both of these were perfect squares, but in the vast majority of cases like here, it doesn't matter. So it's good to keep in mind that any irrational number attached to a rational number, a number that we call it, or an integer, must be irrational, and that will come up big. So your assignment for tomorrow is to find the sum of the two diagonals when the edge is 2. Okay? So you need to find the sum of the diagonals. And that will be good, sum of the diagonals. And that will be good practice for you, because a lot of you like watching a YouTube video. The sum of the two diagonals. Okay? So I'm going to do that one as well. And something weird's going to happen there when I do it tomorrow. But we'll talk about that because I'm going on 10 minutes now. The light's blinking.